presenter is Dr. Adnan Tahir. He is Associate Professor in Department of Environmental Sciences, Comsat University, Islamabad. Dr. Tahir has expertise in snow and glacier modeling, land cover estimation, application of GIS and remote sensing in water resources, and climate change impact on water resources. Today, Dr. Tahir will be talking about the simulation of river flows in the Karakoram and Himalaya region using snow melt runoff model and RCP scenarios. So now I will request Dr. Tahir, sir, it is question. Please complete your presentation within 10 or 15 minutes. Thank you very much.
Okay, thank you. Thank you very much for inviting me to talk in this seminar. So without wasting any time, I will start my presentation. Today, the topic of my presentation is simulation of river flows in the Karakoram and Himalayan region under RCP scenarios using snow melt runoff model. So as we know, upper Indus Basin of Pakistan, it supplies more than 70% flow to the downstream agriculture areas of Pakistan during summer due to the melting of snow and glacial ice. But estimation of the stream flow under future climatic projections is a prerequisite to manage water resources properly. There are various hydro modeling techniques which are being used. Models from simple to complex models are being used around. But for complex model, there is a lot of input data which is needed. But unfortunately, that detailed data is not available from upper Indus Basin. Only the basic data is available. So simple models like snow melt runoff model can be integrated with the field data and remote sensing snow cover data to simulate the snow and glacier melt runoff from subcatchments of upper Indus Basin. So we have used that snow melt runoff model to simulate the flow from two subcatchments of upper Indus Basin, namely the Astor River Basin, which is about 4,000 square kilometer in catchment area, and the Hunza River Basin, which is about 13,700 square kilometer in catchment area. First, we simulated the flow, we calibrated the model, validated the model, and then we used representative concentration pathways RCP scenarios 2.6, 4.5, and 8.5 to simulate the flow under these climatic scenarios. First of all, I would like to present some hydroclimatic behavior of this study area, Astor Basin and Hunza catchment, which are sub-basins of the upper Indus Basin. Mean temperature is slightly higher in the Astor Basin as compared to Hunza Basin. And in the right panel, B graph, I have presented total recorded precipitation in both catchments. Then in C panel, I have presented mean runoff in millimeter of water depth. So we can see that peak discharge in the Astor Basin, which is in orange color line, achieved in June to July, while in Hunza Basin, it is from July to August. And snow cover variation is higher in Astor River Basin as compared to Hunza Basin. One of the reasons is that Hunza is highly glaciated. About 25% of the Hunza catchment is under glacier covers, but that glacier cover in Astor Basin is only 5 to 7%. Now I would come directly to the snow melt runoff model. It has a few parameters which have to be calibrated to run that model. So we have temperature lapse rate, degree day factor, runoff coefficient from snow and rain, rainfall contributing area, critical temperature, recession coefficient, and time lag. Then we have few input variables, data that is precipitation in centimeter, mean temperature, or we can use minimum and maximum temperature, and then snow cover maps in snow percentage. So this model is run on daily data. So we obtained that data from WAPDA and PMD. Unfortunately, we had only 5 years of data for both catchments, which we could obtain from two organizations of Pakistan. So we run the model on these 5 years. Alongside the parameters and variables, there are certain catchment characteristics which are also used in the model to simulate the river flows, which are area of the catchment and mean elevation. So these characteristics were extracted from the digital elevation model of the catchment areas. Snowmelt runoff model can be applied basin-wide by considering whole catchment as one unit, or we can apply snowmelt runoff model by dividing the catchment areas into elevation bands of 500 meter or higher. In this presentation, I will present only the basin-wide application. And if anyone want to consult zone-wise applications, so our published paper is there to check the details. When we applied the basin-wide application of the snowmelt runoff model, we found the following parameters. Lapse rate was calculated from the available temperature data from the catchments, and degree day factor was estimated either from previously reported values from the literature, or during the calibration mode we estimated those degree day factor values for snow and glacier. And similarly, the other parameters were estimated during the calibration of the model. Once the model was calibrated with these parameter values, we run the model on the available data. We calibrated the model over the year 2000 and 2001, and then validated the same parameter values on the next 3 years of available data, which was from 2002 to 2004. In the calibration phase of the model, we got Nash-Sutcliffe coefficient value of 0.93 for the Astor Basin and 0.87 for the validation period in the Astor Basin. And the model simulated the low flow as well as the peak flows quite well. Then we applied the same model on the Hunza River Basin, and in the calibration stage, we got the values of 0.86 and 0.86 in both calibration and validation stage. If we talk about the entire efficiency of the model in terms of Pearson correlation coefficient on the entire data period, we can see that model has simulated the flows in Astor Basin very well as compared to Hunza Basin. But in both cases, the efficiency was more than 0.9. So the model worked very well in both the catchments, and for the year-wise application of the model, the efficiencies are presented here in terms of difference of volume between simulated and measured flow and Nash-Sutcliffe coefficient. And in the Astor Basin, year 2000, which was calibration year, was the highest coefficient value, and but Nash-Sutcliffe value was never less than 0.82. And for the Hunza River Basin, the same year 2000 was the best year in terms of Nash-Sutcliffe coefficient value, and NS value was never below than 0.73. So we can say that model performed well in both the catchment. Once the model was calibrated and validated, we used the base flow as the flow of year 2000 and applied RCP scenarios. There are some RCP scenarios for global level, but we use the values which are downscaled for upper Indus Basin by Su et al. And we use those values of the mean annual temperature and mean annual precipitation, in which increase in temperature and precipitation is shown. We applied these models, these values of climatic scenarios in snowmelt runoff model and projected the future flows. And what we get was that for mid-21st century, RCP scenario, application of RCP scenarios shows that there will be an increase of flow in both catchments. In Astor Basin, there will be 13 to 29% increase in the flow, while in Hunza Basin, there will be 21 to 44% of increase in the river flow. When we applied the end 21st century RCP scenarios, we get that in Astor Basin, there will be 11 to 58% increase in the flow, while in Hunza, there will be an increase of 14 to 90%. But of course, as Dr. Habib and Dr. Ghulam Rasool talked, that if these scenarios come true, then maybe after generating a few years of high flow, the glaciers may deplete, and then we will not have any more flow in from the upper Indus Basin. So these flows are only if the glaciers sustain for 100 years or 150 years. So under these scenarios, we will get this increased flow. And if we get this increased flow, then we will have a problem that we do not have any more storage to conserve all this flow. And either we will get flooding in the summer season, or we will be in short of water during the winter season. So I will come to conclusion from my study that SRM simulated the river flows efficiently in both the Astor and Hunza river basins, which are subcatchments of upper Indus Basin, and application of SRM under climate change projections suggested that an increase of 13 to 58% in Astor Basin and 14 to 90% in Hunza basins may occur if glacier cover sustains until then. SRM is found to be an effective tool for simulation of snowmelt runoff in the data scarce catchments, for example, those of Karakoram and Western Himalayan region, where we have limited data. So we can integrate that data with remote sensing snow covers and run those models easily. However, the availability of in situ precipitation data from high altitudes of Astor and Hunza may improve the runoff simulations. And we have currently one collaborative project from Chinese partners from Yunnan University Kunming. We have installed some river flow and weather stations on Batura Glacier. Now for 2 years, we are monitoring the some of the variables, and hopefully it will last long and we could get longer data. So thank you for your attention. It's all from my side.
Thank you very much, Dr. Saf, for your nice presentation. This is the end of our second session. So in